Got it. Okay. Yeah, good morning, everybody. Happy Thursday. Tuesday, let's see, what did we do? We got our environment set up a little bit. We took a look at the code. We did some very brief introduction to the objects of Git. Does anybody remember what the three objects are that we worked with? I want to take a swing at that review.
Got a index and a head, and then there's I think something in between.
Okay, those are the trees. That's what we're going to talk about. Index, the head, commit, and the workspace. But what are the objects that so the trees kind of have to do with the status of your workspace. The objects are what you're working with to change the status of. They're all SHAs. I'll give you that hint. What kind of SHAs are they?
Go ahead, Jeff.
No, go on, Sean. You got this.
A commit, a tree, and a blob.
Yes, commit, tree, blob. So we poked around in a .git directory of your workspace and observed that that's where the actual database is for all of your history and your commit, what's committed. And we looked at how those basically, the blob is kind of the lowest level leaf of your graph. And that is the content of the thing that you're putting in to Git. And then the blob is referenced by a tree, which can also reference other trees, and that creates your directory structure and contains things like the permissions of the blob and the file name of the blob. The blob itself has no name; it's just content. Then the next level up is the commit, which actually has a tree, so something that manifests into a workspace or directory structure on your disk eventually. But then it also has things like a pointer to the previous commit and your comment and authorship and date. And so that's what Git uses to build up its graph of what you've done. So all these commands that we run basically move these objects around between your workspace and your index and your actual repository, which there is a pointer to that always called head somewhere in there. So that's what we'll start to dig into a little bit today, actually a lot today. So in the process, to do that, we will begin to run the project. So I've been debating how to start out this most effectively. I think what I'll do first is tour around the documentation a little bit. I did some reorganizing this week after our class, realized it was not in very good shape. So I pushed some changes up to the github.com repo. Nothing that will affect you except for maybe that the bug fixes in that append alias script, if that's still an issue for you. But just the documentation. So I want to show you what's in there in case it comes in handy for you later on. And then we'll begin to I think we'll begin to touch on the concept of these three trees that hopefully you got a chance to look at it with the homework. And then just kind of go for it and start to make changes, have your team begin to make changes. I think I may do one sort of exercise to try to simulate a merge collision, because that's probably one of the first things you run into when you do start to make the changes. So are there any questions left over from the last session before we get started, or from the homework? Okay. Oh, let me do one thing to plug DRW a little bit. I know that you'll get more of that later, but I've just had, like I said, a great experience with DRW, and so have a lot of code platooners. So I wanted to point out kind of what just you would expect to come into DRW, and this is probably similar for other fintech internships you might see down there. But you'll come into the team at DRW, whichever one it is. There's been more teams that have stepped up to offer slots lately, which is really cool. Love that support. And those teams they tend to be shared service teams, and they tend to do some web development, but a lot of what they call DevOps. So you would maybe do some web, but you definitely would do a lot of Git and Bash, and I would also recommend Vim. Like those are the kind of the three horsemen of your tool set at DRW, at least. If you know Git, you will impress people because most people don't know Git very well. So these basics here, this course actually was prompted by the first code platooners who came in to DRW and just needed they needed this grounding in order to really get going with whatever team they were on. So with that said, there are a lot of different teams that sort of you can branch out to. Our interns have gone from being on our own shared services engineering dev engineering team to be part of a network. What is it, like a fiber optics, like a fiber tap team. So everything that comes into DRW gets stored somewhere, which is a huge amount of data, of course. So Greg Glover is on that team. If you know Sky Bay, she's on the cybersecurity team. Hank Moon is on a business services support team. Holly Bird's on desktop. I think she's going to New York if she hasn't been there already. Jordan West is on my team. Beck Zumabayev is on something called EEIO, Equity Something Index Options. So he's on basically a trading desk. Michael Whalen in data services. Emma's on the UX development engineering. Michael Orland on a infrastructure support team. They do some web stuff as well. And then we have another person on the desktop team as well. So it's neat to see how people come in, and then they're able to spread out and do different things. And we've kept most of the people that have come, actually. We've interned about 15, and we still have about 11, I think, in-house, 10 or 11. And almost all of those have, the ones that have left have left kind of on their own terms and been able to succeed in other places very, very capably. So that's another thing I love about this program. So anyway, for what that's worth, let's go look around at some stuff. Let me share my screen here. Okay, can you guys see it okay? We are in the tags repo. And so this is, if you notice, the github.com/Walquist, or that's the org or user, and then the repo, it's the way all GitHub URLs are laid out. You're either going to be at the org level or the user level here under github.com, and then your repo will be the next component of the URL. I tried to make this README here to get into the actual docs, so you have a path over there. And I took some things out of here. If you're paying probably closer attention than you needed to, there's some things that are moved into some other places. But this is the foyer, and then the curriculum introduction. This goes to, if you notice the link at the bottom, this is the actual root of the documentation site. So I used Sarah's XKCD. I thought that was really appropriate. So thank you, Sarah, for that. And then down here is the layout has kind of the all the links that you'll care about, basically, I think, for the most part. So you probably looked at the object and trees handout. We'll touch on that in a minute. We went through the pre-work Tuesday. The syllabus might be interesting. I'll actually keep this on the side. This is sort of a checklist of what we hope we cover. We won't get to all this, but it's be a good reference for us to see if we've hit the high points at least. So the only other thing, I think there's a reference to Unix in here. Yeah, basic Linux command is the only other page, or maybe not. Yeah, I think I probably called it something else. Okay, let's see if we can find it when we get to that point. But let's go into the objects and trees handout. So I'm not going to touch much on the objects because we've done that already. Pretty much covered that. Here's that graph or that table that I had messed up yesterday that I fixed. So basically, things that are in Git, things that are in GitHub, and things that are in only one or the other. So, for instance, both have concepts of repo. Git has clone, but GitHub has fork. Git has commit, push, merge. GitHub doesn't. That's not a GitHub thing. Git has pull, so git pull. GitHub has pull requests, which are something different. And similarly, org team, collaborator, org owner, all these role-based things are GitHub side stuff. So that helps with finding your way through the matrix a little bit. Git repo. So yeah, we covered this. This is a handy little command if you want to know what your current SHA is that you're pointing to with head. You can do this rev-parse, git rev-parse. Anything else? We talked about cat file. I don't know if we use -t. That just tells the type of the object. We use -p to print the object, as in down here. But -t could be useful. Although in the context, it's obvious after a while what type you're working with. We talked about the formats. Some exercises here. Yeah, we pretty much covered this decently well. So I'm going to breeze through here unless there's any questions that come up as we look through here. Obviously, these SHAs are not going to be something probably that you'll actually see. That they'll be in the same place but different values, just because of the hashing, the way the hashing works.
Hey, Chris, I had a random question about the hashing.
Sure.
Was it, correct me if I'm wrong, but is it the first 2 or first 4 of the hashes that points to the directory that the commit is pointing towards, or am I wrong?
The first 2 letters, yeah, when you're looking in the git.git/objects directory, and assuming it's all unpacked like we did with that script that we ran, then that's the layout of that directory. Git uses that in order to partition the objects, partition the files across directories. Because at least in older systems, there's a somewhat small limit for the number of files you can have in a particular directory. So theoretically, you could put it all in the same directory, it would be just fine. But because of the limitations of the file system design and architecture, sharding it using the first 2 characters of some random SHA turns out to be a great way to uniformly distribute it across a much larger set of directories. So that's the kind of some of the background for why it does it that way. But yeah, yeah, this blob would be in .git/object/2d/45b22, etc. And that's where that, you cannot actually look at it. If you cat it, you can't see anything because it's compressed. But Git cat file takes care of uncompressing it and showing it to you in the way you expect. Good question. So, okay, SHA containing contents of the Git ignore file. Okay, so that's another example of pulling out things from the database by SHA. So, and then I've included some things from gitscm.com here. And actually sprinkled all throughout the documentation, you'll see references to gitscm.com. It's an excellent place to go for Git, authoritative Git documentation. Scott Chacon, actually, he was a GitHub employee. He may be like a contract. He's still associated with GitHub, and he loves to teach and write. So he actually visited DRW back in the day, and was really helpful, and continues to be so. So gitscm.com. So yeah, he draws helpful pictures among other things too. Let's see, shots in repo. Okay, so here we are. 3 objects. Now the 3 trees. So all right, so who's been able to do the 3 trees homework? Has that been able to fit into your schedule? It's okay if not, but we'll go through it. So let's actually go into our repo. I'm going to clone from my own repo, but you guys should already have one that's cloned from your team lead's fork. So feel free to go ahead and just use that. And we will, I'm going to just reclone just to make sure that I've got a fresh copy. Now you can use, you'll use HTTPS protocol, but I'm just going to go ahead and use SSH protocol here since I've got it set up. My thing tags. Go into tags. Okay. So let's see if we can look at some trees in our existing repo here. So do you guys have your aliases there? You might want to just try GS to see if that works. That should be short for Git Status. If not, you can just go ahead and type Git Status. So let's start there, Git Status. So what is this telling us about our trees? As we see here, the 3 trees, as I briefly referenced before, are kind of working from kind of closest to you to farthest away from you. The closest to you is actually, I would say, your workspace. It's the things you can look at without using Git. It's what's manifested for you out of the Git repo. The index is an intermediate place, kind of more toward something that's going to be committed. So you'll find things there. Actually, you won't directly look at it in most cases, but there'll be trees that have been shot into the database in preparation for a full commit. So you'll have sort of a partial commit that you're working on, I guess is one way to think of it. And so you build up your commit basically in the index or in the staging area. And then of course the actual Git repo is referenced by head. So head points to things that are already committed. It has nothing to do really with anything that's in the index or your workspace. If you're working with head, it's a full commit. It's in there. It's done and dusted. So that's what when we're doing things like the Git Status. We're looking at where things are at with respect to workspace, index, and head. So let's explore what I mean by that a little bit. So if I were to, it says working tree is clean, nothing to commit. So if I were to, let's see if code works for me this morning while I'm in Zoom. I think maybe Zoom might have. Haha. So not sure what I did, by the way. I might have like turned off some graphics card switching or something in my system settings that made code work for me in Zoom. If you guys ever need to go present and code at the same time, it might be helpful. But let's make a change. Okay, so there's that. You might find me using sort of Vim-like stuff in code, which you can do. So that's written. So I made the change, and now what is Git Status going to show me? Okay, so it's slightly different, right? Here it was, before it was just clean, now it's not clean. So change is not staged for commit. What tree do you think that's in?
Would that be your head?
In the index.
Well, it's not staged.
Yeah, it hasn't been added yet, so it's in your workspace.
Exactly. Yeah, not
Third,
staged.
third guess was good.
Say
It's
again?
got to be one of the three.
Third guess was good. Yeah, so not staged. So that's a clue that it's it's not the index, because the index is the staging area. It's in red. So if you've got color coding or syntax coloring turned on, that's going to be indicator that it's in your workspace and not index and not in your repo. So how do you get it into your index?
That would be a good add.
Yeah, you can say git add readme, or you can say git add dot, which is everything, all directories, all the way on down, however many there are. It adds everything, just both great and terrible. Little by the way, if you're not familiar with git ignore, this tells you what not to include in things like git add or git status. So look, if I had a like VE and V, for instance, VE and V, well, actually it's not here now, but if it were, it would not show up in my changes, or it wouldn't show up in my status. So I can actually touch it just to make it a file, so there's something there. So there's something there, but it's not showing up in my status. If I were to take it out of my git ignore, then it would. Right now it says, oh, you got something I don't know about, because I'm not ignoring it anymore. So it's just a way to kind of, say, don't worry about these. I'm never going to put them in Git, just ignore them, because I don't care about them going into source control at all. So you'll end up, there's kind of standard Git ignores for different languages and systems, but I just kind of add to Git ignore as I see things pop up that I need to ignore. So I don't worry about pulling them down from predefined places. So anyway, where are we at now? So we've got this thing. Of course, I've also modified it now. So I don't really care about this, and it gives me some hints to do, what I want to do, which is just to restore it to what it was before. So I can just basically throw away whatever changes I might have made. I'd probably put VE and V in a different line or something that was fine. So it takes care of that. So I discarded my changes in my working directory. Didn't change the index, didn't change commit, just the working directory. So now where is this thing now? The readme.md. Actually, let me ask that another way. In what trees have changes been made?
Now you're into the index. That's where like commits sit before, or yeah, that is where added files sit before there.
Right. Yeah.
And the reason you changed the language is because we haven't moved the file or anything. We just have a reference to it now that says that that's what we're going to want to commit when we get around to it.
Yeah, we haven't, when I did a git add, the file didn't go anywhere. And the file didn't change with a git add. But the state of the index changed. So now the change is not only in my workspace, it's now also in the index. So now, what another way to say it is now my workspace and my index are the same, and now the commit is behind now. It's behind my changes that I've got. So I'm kind of ahead with my workspace, ahead with my index, and now if I'm ready, I can catch the commit up to what I've done. But I haven't done that yet. That's why it says to be committed. So, and then it also says if you want to unstage, you can do this. I did the restore up here without a -- stage, like here. But if I use -- staged, let's do that. Okay, what do you think Git status will show me now?
Readme's red again.
Exactly. So important to note, it doesn't change the file itself on the workspace. This command, it just makes the index forget about it. So now the index is back. The index actually matches with the commit now. So I've sort of moved it back to where it was, because there's nothing different between the index and the commit is what this status tells me. But the difference is now between my workspace and my index. So we're moving toward kind of an understanding of how these statuses interact. So so of course, if we do the commit, that basically will bring the commit up to sync with what is already in our workspace and what was in our index when we did the git add. So we can do a git commit -m a commit, and that's really all we have to say, because it knows it's going to commit whatever's in our index. Commit. Oh, only
3 M's.
What do you mean it's not a commit? All right, so now what do we expect to see when we see Git status?
I guess ready to be pushed up to your GitHub, I guess.
Yeah, it's all clean again, working tree clean. So we made the change in workspace, we git added it to bring the index up to sync with the workspace, and then we did the git commit to bring the commit up to sync with our work. So, and notice it gives you the SHA of the commit that it makes. So if we do a git rev parse with head, that does resolve to the same SHA. So Git will show the first 7 characters by default. You really only need the first 4 unless there's some ambiguity in that. So okay, so that's kind of a very, very brief introduction. So let's go a little deeper into so git reset. So this is it took me a while to wrap my brain around reset. because I didn't understand these three trees and kind of what they were. But once I, it's almost just memorizing what's going on there. It's logical, but it's a strange name command for one. I thought, what's being reset? What are we resetting to? And I think it's because trees are being reset to a state that exists in the repo. So if we want to go the other way, say we have this commit and we don't like it and we want to change it. Maybe there's, instead of one file, there's 100 files, and we just want to change one file and then put it back in the repo. So we can, the key to reset is the target. So the target is always a commit. It's not our, the target is not the workspace. It's relative to the commit that we tell reset about. So what do I mean by that? If I say git reset, if I say git reset head, what happens? Nothing at all. And that's because of this particular scenario. I've got a clean workspace. I'm saying reset everything to just what head is. And well, it's already what head is, so nothing has to happen.
If you had messed up your files, meanwhile, and did that command, then would it restore it to what it was when you committed?
So like if I made another change to a file.
Yep.
So let's make a change here, add some space. So, okay, so now the file is modified, right? Our workspace has changed, but nothing, our index and repo have not, or index and head, I'll say. So, what happens if I do a git reset head now? Okay. What happened there? Git status. Okay, so manage.py is still modified. There's still nothing that's staged for commit, right? It would say so, and it would be in green if there were. So this is kind of where we consult our table here. So I did a git reset, and that is basically this manifestation of reset. So what I did was I reset something back to head, which means basically I change head, and because I said head, it just changes head to head, which is a no-op. And it also changes the index. And well, the index is already also like head, so that's also a no-op. And this one doesn't mess with the workspace. So basically, again, nothing happened. Let's make it interesting. Let me get this, or not commit. I want to get checked out. So if here's a way to, I think is what you're getting at, Don, is if you want to revert back to what was in the repo, you can do a git checkout, and it just makes it back like it was. It throws away your changes in the workspace if you do this to specific files. So now we're clean. Let's go back to what I was talking about, where we want to move things back. So the way to make reset work for you in that sense is to not point to head, but to point to something, the commit before head. And the way you say that, one way to say it in Git is to use a caret, which means parent of head. So I could say that. I could also say, if I look at my graph, I could also just copy paste this and say git reset and say put head back to here is what I'm saying. So that would also go down to the same thing. So I'll go ahead and use this syntax. and then verify that that means the same thing with git rev parse. What's my head now? I think it's that, yeah, 8961, blah, blah, blah. So now I've just moved things back one commit. What have I moved back? I did the default, which is mixed again, so that's going to be this behavior. So I effected the latest commit. We verified that. The head has changed. What about the index? Anybody want to guess what the index looks like? I do git status. Did the index change too with the default behavior?
I'm gonna say no.
I would like to think so.
Okay, so what would git status show me if the index changed as well?
It's going to be all green things.
Would it not be in
Yeah.
line with your reset?
I moved the head back. I moved the index back. What happened to the workspace?
It should still be there. It'll know that there's a change that hasn't been stated.
Yeah, nothing happened to the workspace. So, but with respect to the index and the commit, now it looks as if I've just modified this thing. So I basically moved my state back to where it was before I did a git add. So this thing has never changed on disk during any of this, except when I first changed it. So hopefully you start to see that's what reset will do for you. And that's the dash mixed. If I wanted to, so now I can just go forward again. I can do git add just like I did before. I can even go back and find my commit message and use it again, or I can change it. Something. Of course, even though the content's the same, that the commit is different because of different date and comment text, et cetera, et cetera. So now let's do the other one. Let's do the git reset -- hard. Okay. So that's again back to that commit before most current head. But now hard has changed everything. Hard has just yanked everything back one commit, including the workspace even. So there's another way to throw away your changes. Is do a hard reset, and everything will be put like head is. Except if you don't have anything committed, right? If I touch a new file, all right, and then I do a git status, it's untracked, so I can reset it to whatever I want at that point, and it's still an untracked file. Git doesn't know about it yet. It's not the same name as any file in Git. It's just out there, uncontrolled. So, any questions so far? Is that making sense? These are the trees, right? So we're using the trees to manipulate the objects. And as you begin to work with code, it begins to be important to, or efficient, I should say, to be able to kind of back something out of the repo and work with it some more, and then put it back in the repo. If you have files to change, or you forgot to add a file to a commit, you can do a reset -soft. I haven't demonstrated that yet, but let's go. Let's see, where was I at before? So let's reset ourselves back to where we were before. Probably this guy. Yeah, it's good enough. So that moves us up a couple. So now if we do a reset dash soft, what's Git status going to show us now? So I've moved my head and everything along with it with the hard up to the commit that where I changed the README, and then I moved back with a soft one commit.
But a new file is still going to be there untracked, right?
Yes, because I haven't done anything with that. That's correct. What there should be something else that it will show me as well. Will it be in? Will it be uncommitted? Will it be in the index? Will it be both?
I think you're back to a changed README.
Yes. Yeah, it's changed, but notice that it's now in the index because I did a dash dash soft, which only changes the commit. It doesn't change the index and it doesn't change the workspace.
Yeah, so you have all the files from the future commit is now in your workspace, and you could, in theory, if you wanted to, commit them here.
Yeah. Yeah, I just left the workspace and index alone and yanked the commit alone back. And so now with respect to that commit where it is now things look like they're in the index. So yes. So okay, I think we're starting to get the idea of that. So kind of here's another picture of it. It's the same idea, it's seen a different way slightly. But the key is that target, that last argument to get reset is where you're going, and the options that you give it determine how much of it comes along. Do all three trees come along, or does one or two of them come along with that reset? So, all right, let's see, what is it, 9:45? Let's take 5 minutes to get started in the actual typing and collaboration and project exercise here. So back away from this. Back away from the syllabus, go up to the top, use the home page. So we want to be in, there's another page I was going to show you here. Oh, common Git workflows. Yeah, let me put that up to the side as well. And let's also go back to the beginning of here. We'll look at the Git diff stuff a little bit later. I'll show you maybe one or two things in here just to introduce the project. But now here's where you guys begin to make changes that are, let's bring up source tree here. So where am I at? File status, origin about page. That's good. Here we go. Master branch of your repo. Now this looks a little different for me because I've made some changes up here. You guys are probably still down here under empty Django web service. And if you're not, let me know. Or you can just do a git reset -- hard to this SHA, and that will put you in where you need to be for this the purposes of this exercise. And this SHA should be the same for everybody. This 04E70. So maybe the first thing you check on your environment is what branch you're on. Okay, it should be master, and then you do then you see where your head is. So if nobody has done anything to, to pull changes from the original Git repo, then you should be just fine. I'm not just fine, so I'm going to do a reset over to where everybody else is, which is this 04 EE70 EE. Yeah. Okay, so it should be empty Django web service. Should be where we start. So
is there something we can do that will show us our SHA prefix?
Your prefix? Well, you can see where your head is by doing the rev parse. If is that what you're asking?
Okay, and that doesn't change anything.
Doesn't change anything. It just tells you where your tells you where your head's at. Could be handy in a lot of contexts. But if you want to change something, you do a reset. And if you want to change everything, you do a -- hard, and then it changes your workspace, index, and your commit.
What's the difference between git reset and git restore?
Git restore, I believe, well, the way that it's portrayed in these, these hints that it puts on the command line is it just operates on a file. Right? You
Okay,
just put
that's
a
what I
file
thought.
right. The reset works on whatever. It works on with respect to commits, right? So the reset operates on the objects. So there's a lot of different options to reset. So there might be something if you dig into the, if you say git help reset, you get a lot of text. A lot of text. Oh my gosh, so much text. But I'm not going to go through that for you or with you because I haven't been through most of it myself for one reason. But the soft, hard, and the soft, mixed, and hard are all we really touch on with reset, and that's really honestly all I've needed out of reset. But it does so much more, like most of the Git commands. Okay, so here we are on. We're on master. We're on the right commit on master now. I am now, at least. And so one thing you might do, and I'll stop talking in about 1 or 2 minutes, hopefully, and you want to try this or circle up with your team, you can start to do these changes. And you can kind of bite them off in whatever chunks you want to bite them off. Like for instance, if you want to, you don't actually have to use, you don't have to start with like the hello world. You could start with the intermediate commits too if you want, or you could just try merging in hello world. And this is where you divvy up these tasks among yourselves and do them on your own branch. So, like for instance, if I was going to my team lead assigned me to the hello world, I would make sure where I'm at. I'm on master, and then I would probably make myself a new branch. Git git checkout -b, and then my hello world. And so that does 2 things. That makes the branch, and it also checks me out on it. So it tells me that I switched to a new branch. Now, if we look here, nothing's happened, right? It's still on the same place as master. It's on the same commit. No changes have been made in the repo at all. But if I do start making changes now, such as if I merge in this origin hello world, then now things are happening, right? It's updating from here to here, and it's doing a fast forward, which basically means what is fast forward? I'm going more than 1 or 2 minutes, aren't I? So it basically says you're on the same ancestor as the thing you're merging, so I can just move you right up to where the thing is that you're merging. So what happens is it's going to look like your branch is going to jump up to origin hello world. And, you know, that's what the graph, that's how it manifests in the graph. Of course, master is still back here. Somebody else is going to branch off master and do something else. And so let's simulate that. So if I wanted to be the other teammate, let me get back to master so I can do a git checkout master. So notice that the merge created commits. It didn't create commits. It moved our pointer, but it could create commits. So it's not working with necessarily the workspace. It's working with commits, unless there are collisions. But if it all finishes, then you've got committed stuff in the repo when a merge finishes. That's my point. So I'm going back to master. I'm going to pretend I'm another teammate. I'm going to do git checkout -b, and I'm going to say, you know, how about this make a template thing? Now, I can't just say make a template because that branch isn't actually here yet. Right? There's only the pointer to the remote make a template branch. So it's probably going to fail. Actually, no, I need to make it something different, otherwise Git might be confused. Okay, so then if I try to do a git merge here of make a template, this is what I was trying to say. Yeah, it says not something we can merge, and that means I don't know about make a template, but later versions of Git appear to be smarter and think, hey, you might mean this. So yeah, let's try that. That's probably what we mean. So now I've got my thing here. So now again, the same thing has happened. So this so far isn't very interesting. You're making changes and you're moving pointers around, and nothing's actually, you know, you're not actually slinging any code. So where it gets interesting is when you try to bring things back to master. So say I go to, you know, bring this change back to master, this my make template. And I'll go over this again. But the first thing you would do is to go and get back on master. So here's where I'm at now. I'm going to pull back this, merge back this thing into the master branch. So my thing was, what was my thing? Make it my make template. That's my branch. And because I'm the first person to do this, it all just works. Right now master hops forward for me. But what if I want to, I'm the other guy, now I want to bring my hello world back in. So let's pretend to be this other guy. Let's go back to master. And now it's saying, okay, you know, by the way, you're different than this remote version of master. You might want to think about that eventually. And I say, yeah, never mind. Let's just do what I'm going to do now. So now I'm going to bring back the other one, the hello world one, into master. Okay, why does it say that? Mario master. Okay. It says I'm already up to date. So that must mean that everything that is in my hello world is also in make a template. So this is not a very good example. So let's do something on my hello world. So let's check out my hello world again. And I've probably got something in tags that I can change, like views. My world. Okay, so I'm going to add this little change, and I'm going to do my status. And I'm going to add it, git add. And I'm going to commit it, git commit. Okay, now let's look and see what we look like here. So here's where we started at empty Django web service. We merged in so here's my make template that got pulled into master. We've got origin hello world. And where's my hello world? It's all the way up here. So let's bring that in. So again, to merge something, you have to go to the place you want things to come to. So go to that place, which is going to be master. We want to bring it into master. So let's go there and then reach out and grab it by doing a git merge of this branch with my changes. Okay, here we go. Now we're getting interesting. So let's stop here, and then we'll, if you want to play with, making some changes on master and doing a git branch or git checkout -b to make a new branch and making those changes, feel free to do that, or just take a break and we'll pick up in 10 minutes at about 10 after 10. Excuse me, 10 after 10. Any questions before we break?
Thank you.
Okay, see you in 10 minutes.
Thank you.
We're back. Okay, any questions before I jump back into it? So I realize I dumped a bunch of stuff on you there at the end. So let's go back over that a little bit. I all of a sudden started using branch commands, branching, creating branches, and then I threw in a merge. And so let me just talk a little bit about branches because I haven't covered that at all yet. So you've seen them, if you looked at the ADOG output and you've done the git branch command to see where you're at. So what are they and how do they fit into the objects and trees that that we've been working with? Let me share my screen again. So yeah, we have our source tree. So do branches, are branches in the repo as far as, the objects go?
No. I believe they run parallel to like the master, and then it's kind of where you do changes from the master, and then you merge them back together once it's approved.
Yeah. Yeah, they're basically just tags on existing commits. Like if you create a branch, there's no SHA that gets created when you make a branch. It just tags an existing SHA. And they're commit SHA specifically. And there are notions in Git of tags, which is another kind of branch basically, but we're not going to really talk about those today. You can make sort of static branches, I think is a way to just to think of tags. But yeah, they're just little named commits basically, and they behave in a way, the symbolic reference that we use or that Git uses with head. Notice that head points to the branch you're on, and then that branch, when we do a Git reset, you know, the branch moves and head moves along with it. So when you're resetting stuff, you're resetting the branch, you're moving the branch itself. So like if we were to see what's a good spot here. Let's just make a branch off of this, add a layout, just for practice. So we go to our command line, we look for the easiest way is just to look at the SHA, which is 58ED8. So we can do a git checkout -b my branch, my temp branch will say. And if we don't give it any arguments, it just makes a branch right from where we're at. But if we do give an argument, which is a SHA that exists in the repo already. I've got this commit merge conflict going on first. I want to talk about that as well. Well, let me just hand wave. So if I did that, I would have a, what would I say, 58EDA. So I would have another tag up here that was called my temp branch. And then if I did a git reset head caret to move head back, well, you would also see the branch move as well. So, you know, good to keep in mind. It's really the branch you're changing when you're doing git reset. That's the point. So branches, as I believe I mentioned last time, are tags to local or to remotes, and the convention in Git is to represent the remote as this, you know, this name and then a slash and then the branch name. So for instance, origin/add style sheet is a pointer to that branch on the remote called origin, which shows it, and that's a read-only thing. You can't move that branch around because it's a pointer to something that's somewhere else. But you can make a branch locally and move that around and then go push to that remote place. You can associate with upstream track, Git calls it. You can track an upstream branch and then, you know, pull and push from it. But you can't directly check it out without making a local branch off of that SHA. So you'll see that in practice when you begin to work with pulling and pushing code. So that should help you interpret what Git is saying to you when whatever you're trying to do fails. This is something to do with possibly with trying to use a remote branch locally that's not actually there yet. And we saw a little bit of that even in what I did up here, I believe. It says not able to do it. I forget what the exact wording was. So any questions about branches to this point? One point is that if you do a git branch, like I tried this, that won't work, but I could say git branch, my temp branch 58ED8. Well, that works just fine. Right, there it is. However, I'm not on it. I didn't check it out, which is one reason Git let me do it here. Right? So you can, I've done this so many times. You can go ahead and make the branch and then make your changes, commit your changes, make your changes, commit your changes, and then realize, you know what? I never actually changed to that branch. I made the branch and all my changes are still on master. So what we're doing here will help you recover from that as well. Okay, let's go and see what we can do about this merge collision, because you're going to get these. So what did we have? merge conflict, here we are. We ended up right here, right here. So we wanted to merge our changes back into master. So we switched to master to get in position to receive those changes. We reached out with merge to go grab them from my hello world and bring them into master. And whoops, it's a conflict. And it says tags.views, whoops, didn't want to do that. Tags/views.py is the issue. So what does tags.py look like now? Let's code tags. First, let's see what status says. We can still do Git Status. Okay. Let's just get rid of a new file. Okay, Git Status. Tells us quite a bit, actually. Tells us our diverging, of course, we know about that. What does this mean, by the way? Anybody want to describe what's going on there?
Is it basically saying that you've made changes with your branch that are different than the master that you're trying to push towards? Or am I wrong?
Yeah, it's so diverged. So, you know, it's a graph. Go ahead, Don.
Change has been made by 2 different commits or more.
Okay. Yeah, that's true. It's not, notice that it's saying origin master in this context. So it's only talking about, you know, your branch, which I believe is master. So it is master, yes. So master and origin master have diverged 4 and 4 different commits respectively. So respectively means your branch has 4 and origin master has 4. So let's see if we can make sense of that on our graph here. So here's master. Oh, it even says it here, 4 ahead, 4 behind. What in the world does that mean? 4 ahead, 4 behind. So where's origin master?
So does that mean master in this context is just where you grabbed it from another repo and it's on your local machine? That's the master it's talking about?
Yes, yeah, this master is just your local master. And presumably it originally started, you know, lined up with origin master, but then it's basically saying, you know, you did stuff, you did 4 things, and oh, you know, origin master also did 4 things. So you'll need to figure that out. So here's origin master way up here, right? So if we trace back to where we're at on master here, we're looking for like a common ancestor, because that's what it diverges from, right? When it says have diverged, it diverges from something. So that means we got to find the common ancestor of master and of origin master. So here's origin master, 1, 2, 3, 4 commits, and that's down at empty Django web service, which that kind of makes sense, right? So those 4 commits are the ones I talked about that are documentation commits. And again, your repo will look different, right? This is me coming from GitHub Walquist tags, not the fork, right? So you're not going to necessarily see any of this, you know, this specific configuration or graph, but you'll see something like it once you get going. But yeah, so there's those 4 commits that have taken off from origin, from the common ancestor. And then here we are here. So 1, 2, 3, 4. So here's our 4 commits that have also taken off in a different direction. So it's basically saying, if you want to get back in sync with origin master, you're going to have to, you know, figure out these 4 different things that have happened in each of your worlds and bring them back together. So it's just FYI, you know, and then it gives you a hint of what to do. So if you want to resolve that, you're going to have to merge origin master over here to catch yourself up with what's happened over there. And then once you've done that and made that all work together, then you've got to push it and then catch origin master up with what you've done. But we're not quite at that point yet. So we're still on this this little merge collision issue. So it tells us what the issue is. It tried its best to merge everything else, but there's some things that have changed in both. The same thing has been changed in 2 different commits, and it says I need your help in order to figure out what's going on here. So let's see what we can see in this tags views.py. Okay, so let's digest this. What's going on here? What are we seeing? So first of all, we see that Git has changed our code. It's gone ahead and stuck things in that will make, if we were trying to run this now, it would fail with syntax errors because Git has thrown non-Python stuff into our Python file, which is honestly a little bit annoying, but that's what it does. But it lets us know that, hey, you've got an issue here, you've got to resolve. So yeah, it says, you've got something from head, and you've also got something from my hello world, and they don't match up. They're on the same line, just about, but they're different content. So what are you going to do about it? So part of this is finding out which change comes from where. So what does the stuff on head come from? What is our head?
That's from the master, correct?
Exactly. So this is what's on master. Okay, so master's here, and master came from, we just basically merged in hello world, right? So that's where master's at. We're trying to bring in our hello world, which is way up here. And so, we're pulling this guy into what master is. So this thing here it basically looks older to me. The kind of change that we have here is this very, very primitive way to return a code, return a response. And this change up here has gone further and made a template, and it's just more advanced code. So what do you think the right thing to do here would be? Which one do we want? Do we want one, the other, or both?
Accept current change.
Okay.
Would it also help to check the time of the commits to kind of make sure that you're grabbing, I guess, the most recent one?
That could be a data point, but most recent doesn't always mean the latest. Somebody could have made this change a long time ago, and then you come along and make this change, and this would be most recent, but it wouldn't necessarily be the right change. So you have to really sort of unpack what am I looking at, who's done this and why, and which. There's actually 4 different possibilities, right? One is you take the current change, you take the other change, you take both of them, or you fold it into some kind of interleaved, combined change that is really what you want. So, and that's why Git does this. It's like, I don't know which one you want. I can't determine that or make a good guess based on, what's there. They're changing the same place in the file, and I don't know what to do. So that's kind of what you're seeing here. And VS Code gives you these little buttons to push. You can use them or not, you know. You can accept current change, or you can just go ahead and just delete everything except the current change. And that accomplishes the same thing, right?
If
So-
if two people had each added a function to this file and the functions were apparently different, then what would be happening right now?
Well, if the function names were different, then you would get the conflict in the file because, you know, the function names would not line up. If the function names were the same, then you would probably get this file being okay. But then wherever those functions were defined would be a problem. You know, if they were defined in a different file, then those files would probably conflict, and you'd have to decide how you want to define that function going forward.
So even if there wasn't a clear conflict in the code, we would still be looking at making a choice.
Well, so Git's merge tries to do as much as it can for you. So if, you know, if, say function A was defined in file A, function B is defined in file B, you might end up getting both of those files merged, and then if the function has the same name, which, you know, is possible as well, it may just all go in, but then when you run it, it's going to be a logical issue because, you know, you're probably going to get some sort of a runtime error. You know, if you've got the function defined, some ambiguity is going to come into play.
But if you and I both make a change in abc.py and mine is def George and yours is def Fred,
Mm-hmm.
will it ask us to make a choice, or will it look at that and say, oh, that works?
It kind of depends on where they're defined. Now, if they're the same line, they're defined on the same line, then you'll probably get a conflict that you'll have to resolve. If they're defined elsewhere, like if one is at the top, one's defined at the top, one's at the bottom, Git might be okay with that. I mean, Git doesn't know Python. I mean, that's one thing to keep in mind. It doesn't do language aware merges. It only deals with content that, you know, that it's line by line. So you can't expect Git to read your code for you, if that makes sense. It's reasonable that it would, but it doesn't. So it just purely, you know, content-based merging of you know, of files that are readable. Basically, it doesn't merge binary, for instance. It just says can't merge this. Choose one or the other. It will show the conflict.
If you change a comment at line 17 and I change a comment at line 43, it'll decide that those were two unrelated changes and let it slide.
Probably will. Yeah. Probably will. So let's assume that this is good. We won't know until we test, of course, that ultimately that it is, but now what's our Git status look like? Where are we at in our merge conflict resolution workflow? So it still says they're both modified because I have to do this to tell Git that I'm done. So let's do this. And notice I don't have to type the whole path. I can just type tags, and that's unique enough to say, you know, just commit stuff that's tags and under, and views is the only one. So this is a good shortcut. All right, so now it's you know, it doesn't show specifically my index, but it does say they're all fixed, and I'm in merge state. So, you know, now I can go ahead and commit like it says. It walks me through here pretty capably. And it won't necessarily say, you know, tell me that I've merged a particular branch. If I want to know about which branch I've merged, I probably need to say so, right? Okay, so how are we doing here? So here we go. There's our merge. So now I'm 6 ahead, and 6 ahead of the common ancestor and 4 behind the remote master. So one thing about branches is Git expects them not to hang around once they're merged. Like it, you know, most workflows expect branches to go away when they're merged. If they're not merged, it will tell you, you can still throw them away, but it'll tell you, hey, you haven't merged this yet. It's not, there's not something else that's pointing to it. So you might want to rethink whether you want to throw it away. But in this case, it's merged. My hello world is merged. So now I can go ahead and I think it's -D. Hello world. And it does it for me.
Can you say again what that -D command does?
-D is delete.
Okay, thank you.
D is delete. Yeah. So, yeah, I know if I wanted to delete something that wasn't merged, like here's a branch that's not merged, right? It's just sitting out there on its own. And actually, there's no local branch there. Actually, so what happens? I'm curious. If I go ahead and check that out, last GH pages. So git checkout, last GH pages. So it goes ahead and creates a local one, right, to track the remote. I wonder if it cares if I've made any local changes on it yet. It does care. Oh, that's cool. So even though like there's something else pointing to it, but nothing local is pointing to it except this last GH pages branch. So if I try to delete that, it says, yeah, that's not going to work. Or maybe it just is mad because I'm still on that branch. That's also possible. Try that. Okay, so yeah, never mind. There is something else pointing to flash GH pages, so it went ahead and let me do that. Now, if I made a change, that would be a different story, right? If I let's change README again because that's easy to do. So now I've got README modified. Do a git add of it and git commit. And now, if I go back to master, PCOM is git checkout master. Now, if I try to delete that branch, here's what you see. It's like, yeah, it's not, you know, it's not represented anywhere else in its current state, right? Because now it's up here on its own. So there's nothing else pointing to it besides this branch. Now I'm not on it, right? That dot is down here, not up here, but it still says, you know, if you're sure you can do it, but you're going to lose a pointer to it. So, you know, I can do capital D and say, yes, delete it, shout, delete.
Is that just like a force delete command?
Yeah, it says, yeah, I really mean it. Go ahead and delete it. And so it does. So now there's no, you know, the SHA is still there. The commit, we can recreate it if we remember the SHA. But as far as Git's concerned, unless we do something different, it's gone. Even though the SHA is still there, we'd have to reattach a branch there if we wanted to get it back, which we could. You know, we can get it back that way. That's fine. Nothing underhanded about that.
So
okay.
If you and I made changes and you're busy merging and I decide I should merge, will I be locked out?
Locked out.
It seems like it'd be challenging if both of us were making merge decisions in the same changes at the same time.
Right. That's an excellent question. So that goes back to kind of where you're at with respect to local and remote. So let's take you and I. So we each clone down from our team leads repo. And you know, where we start is on master, right? I start on master, you start on master. So are they the same master?
Yes.
Yes.
Initially, yeah.
Yes and no. It's the same SHA, and we both cloned, but we have our separate copies, right? So the changes so my master is it's a clone. It's a snapshot that's identical to yours when we both start. But as soon as you make changes and I make changes, then our masters will be their own thing. So here we are out here, and here's the the rendezvous repo, the team leads repo is over here. So, make changes, and then commit, and then, you commit, and then we both push, right? You push up to the rendezvous repo. That's when the fun starts. So one of us is going to win. Say you win, you get up there, nothing's happened since the last time you pulled, you get your stuff up. And now when I try to go, and there's a conflict, nope. And even if there's not, even if there's the merge would be fine, you still have to. I have to come down here and grab your stuff by pulling before I can then go up and push my stuff. And so that's what we're going to run into when we start to run this project workflows, that kind of stuff. And so that's where I want to move you toward, the top of the hour. By the top of the hour, I want you guys to be trying this, to make changes, decide which changes you're going to make. You can use these as a guide. But I mean, you can change whatever you want, really. But here's some good suggestions. So make those changes, and then you commit them, and then you push them. And so that's when you have to probably resolve merge conflicts, almost certainly. And you do that by pulling out, and you can't push a merge conflict up to a remote repo. You have to resolve the merge, and then push so that merge up here will be a fast forward. We touched on that earlier, what a fast forward was, but a fast forward is basically where nothing has changed up here, everything has changed down here, and you're just putting it on top of where you left off. But in order to get to where it was left off, you have to pull down and make the changes, and so then you can go up here with no conflicts, no collisions.
So is that pull for the merge conflict, is that done by the team leader?
Well, when you pull, you're pulling into your local repo. You're always doing that. So that's always going to be, you're going to be resolving conflicts locally. You can get in a situation where, Don's he's really prolific and he's just pushing stuff up, and you're, doing this deep thing that requires lots of thought and, a few commits, but they're really important. And every time you try to push up, he's done something else. And you keep pulling down and catching up, but you never quite get caught up. So then you've got to go slack Don and say, Don, come on, can you back off just a minute? I got to get this thing in here. And that's not even Git. That's just collaborating, right? That's just the irreducible complexity of your working together.
And if Reno and I make the kind of the same change in it, with two different approaches, then we need to kind of get together and decide which approach we like better.
Yeah, I mean, Git will hint that you're doing that. I mean, there's hot spots in the code, and that's what happens if your code is designed in such a way that a particular file tends to get changed a lot, like maybe a configuration file or some file with a huge switch statement, is another possibility. That's when you may say, well, let's break this out or handle it a different way so we don't always run into collisions. Like that might be a good design discussion to have.
So if the code is the same though, like it's equivalent, like same, then you should be able to push it up.
Yeah, Git should say, yep, it's the same. No issues here. But it has to be like exactly the same. There can't be a space out of place. So, because again, Git doesn't read code. It doesn't know if it's syntactically the same. So, all right. Any other questions, comments?
Sounds like one more reason to make these files as small as possible so that changes are not all in one 3,000 line file.
Yes. Or if it is, make the commits as small as possible. Right? Don't. I mean, Git helps you start to think in terms of change sets because you're communicating with your team by your commits that you're using. And I'll actually show you some tools that you can use in Git you can like sort of code stream of consciousness and make commits locally and do whatever you do, and fix typos and whatever. But then when you go to push it, you may want to share something different than what you've got, your actual dirty sort of messy workflow that you have personally. And so you can actually go and curate and just tidy up your whole commit set and really even boil it down to one commit possibly. And this, this is the thing that I built, right? And then just share that. So that's another option as well, especially if it's kind of modular and nobody else is touching that area of the code. You can just make it nice and communicate it well. And then if somebody does want to dig into it, then they have like a whole nicely packaged change set that this is how this thing is done, right? This is how you change to HTTPS, or this is how you implement this feature, and all the files that it touches are all in this one nice commit, which that could be really, really helpful for team productivity and making your code more easy to change. Okay, let me show you one more thing and then give you some time to, you can take a break and then go and begin to pull some, or take some code and commit it and try to push it up to your team lead repo, and we'll see what happens. But let me show you one thing before that, and that is various ways to get a hold of this code that we're looking at. So you can, so what I did, I merged, that's one way to do it, to merge a branch wholesale. You may just want to take a particular commit, like add an image of the sun, right? What if you just want that commit? So that only makes one change. It does assume that we are beginning to use templates now, right? Because that's what this template thing does. So if you do this, you may end up having to resolve a merge conflict with your teammate who hasn't used templates yet, or something like that. So again, that's something for your project team to kind of sort out and see what has to be done, what can be done independently, what can be done orthogonally, and kind of look at these changes a little closely to see what each of these changes implies. But with that said, if you want to just pull this change, so let's say I'm here. Where am I actually? I'm on master. I've merged that. So I'm up here. And really, just by the way, it's up to you whether you want to branch off a master and do your own thing and then merge back. Or if you just want to work on master and try to get it pull and try not to step on each other's toes, because you're ultimately going to end up on master anyway. At some point, you've got to rendezvous on the same branch in the same repo. So that's, we could talk more about the nuances of that later, but either way, for right now, either way will work. Where am I at? I want to grab this sun image. So there's a handy Git command called cherry pick. So if I want to do just this command or just this commit, I can go find it. And now I can refer to it either by the branch name or by the commit. Git doesn't care. It resolves to a commit ultimately anyway. So, you know, whatever's easiest in this context. So I'll just say 3A9F, which would be just the same as saying origin/add sun image. Okay, and I got merge conflict. So, but I also just got that one commit. I didn't get everything else that came before it. Right? If I'd done a merge, it would have tried to pull in everything since our common ancestor way back here. But I just said, no, I just want this one commit. Let's see if we can do this. And it said, no, you can't. You got conflicts. So what are the conflicts here? Okay, so here's me. I'm just hello world, and looks like some things have happened since I did this. So again, I would have to decide what do I really want to do here? Do I want to just pull in the sun? Do I want to get all this stuff? And let's say, you know, for whatever reason, I decide, no, I just want the image. This could work. So I don't want just this. I don't want just that. I don't want both of them. I want to actually do my own thing, right? So I'm going to, so you know what? Let's keep hello world. Let's I'm gonna get rid of the croft here. I don't understand this stuff. I haven't covered that yet. Let's do that. Okay. Okay, well, let's see. It is an image of the sun, so let's keep this too. Yep, that looks good. So say that, git add, and you know.
Move your terminal up a half inch.
Oh, sorry. Up here, is that better?
Yep.
So yeah, so just git add. And then I may just even say what I did, right? Cherry pick the sun in. And dare I try to run it? Actually, I dare not, because I haven't created my virtual env yet. So I'm going to do that on my own time. Not make you watch that, but yeah, that's a way to just pull in just the change. And then one last, like what you're seeing here, by the way, is just the change from the parent commit. Like if you look at this changes down here, it's only how this is different from its parent. Its parent is this. And you can do that on the command line by doing a git show. That's the analog of what you're seeing down here in this source tree. So if I say git show any random commit, let's do the sun image. Origin add sun image. You know, I'm seeing exactly what source tree is showing me, only in a slightly less readable format. Right, here's what was taken out. Here's what was added. The green, it's kind of hard to see in this case, but the green pluses represent what was added. Here's the files that were changed. And all this stuff here is just the context. That's the same in both places. If it doesn't have a plus or minus, it's just gives you a sense of where things are at that's being changed. So yeah, so git show. That's also referenced over in where am I at? Where did I put that? Hints for viewing repo changes. Yeah, so this is just a little more information on how to know what you're looking at when you do git diff and git show, and ways to use that to see what you're working with when you're working with a particular commit or set of commits. One nice thing about source tree that I think I referenced somewhere is you can actually let's see what's an example. So for instance, this all the way up to hello world is more than one commit. It's actually 3 commits. So you can highlight all those commits and it shows you the sum of those changes, in the viewer here. So everything that's changed between empty Django web service and hello world will be represented in this diff output. Okay, let me stop talking for a bit and give you a chance to try some of this stuff. And you can bring some changes in wholesale with cherry pick, or you could just click on here and make the changes in the, just type them in on your own, however you want to go about that. Note that you have to actually click on specific files sometimes to see what's been changed. But the basic idea is to get changes into your location, commit them, try to push them up to your team lead's repo and see what happens, and just get your hands dirty with that. There's some where's my workflow checklist? Here it is, and under GitHub io/tags. This may or may not come in handy. That's something to try out. This actually does create a separate branch. You can do that or not, whatever you find easiest and most straightforward to understand and work with. So what's it now? 10:55. Any questions before we break off a little bit? So take a break if you need it. Circle back with your team. Choose which changes you want to divvy up among your team, and try going at it for about, let's say till about maybe 10:20, 10:25. Let's say 10:20, and we'll check back in at that point and see how things are going. I'll be back online by about 5 after if anybody has any questions or wants to share screens and do some pairing, be available for that as well. Sound good?
Yeah, thank you.
All right. I don't know if brute force is the right word, but here's one way you could try to approach that. So here I am. I'm going to get up out of this repo, and I'm going to clone another property.
You were not screen sharing if you were meaning to.
Sorry. Yes. Thank you for that. Share. Okay, so I'm CDing up out of my repo, and I'm going to git clone. If I don't say where to put it, it'll just put it in tags, and this of course will fail because I've got one already. But I can, I can make another one. Tags. I can call it whatever I want. Call it read only. Not that it is read only, but I'm going to use it that way. Okay, so I can, I can go there and see. So CD in here, and here's another cool trick. You can check out any random commit. It doesn't have to be on a branch. So it happens. These are so like what was the name of Andrew? What was the name of the branch you were cherry picking?
That was EA24 FEC, set up for demoing embed. It's the 8th one.
Set up for doing so. Was that something on the original or no? That sounds like just your own.
That is, I'm looking at, yeah, I guess it is the original. Yeah. So it should be lower down, I think. Yeah, lower down than that. It should be set up for demoing. Yeah, EA24 FEC. That one right there.
Oh wow, you're going way back in history. So you're back on the Flask branch.
Okay. Oh, we're supposed to be sticking with.
You would start from here. Empty Django. Your master should be an empty Django web service when you start.
Got it.
That
was a misunderstanding.
Yeah, I don't know what will happen if you cherry pick that. But yeah, so yeah, but if you want, say you were cherry picking, add a form and it wasn't going well, right? This guy here, you can, or maybe you just are here. But anyway, let's do with add a form. So I can do a git checkout. Yeah, I can do origin/add a form. So there it is. So now I'm on, because there's no local branch to point to it, it says I'm in detached head state. Right. So what does that mean? It means I can, just what it says, I can look around, I can read it, I can run the web app if I want, see how that works. Right, I can do Python manage.py, run server. And oh, by the way, I forget who it was that had to change the port, but you can give a port argument to the run server, and that way you don't have to change your code in order to to make your server run. So, but I don't have any environment here. Shoot. Okay, so I won't try that part, but if I had my environment set up, I could do that. But basically, I'm on this, so I can look at the add a form stuff, and if I want forms.py, I can just copy it over, right? I can go back up into my tags directory, and so I can say copy, and use ... for relative reference, go get the other one, forms, and then copy that into, I don't even have a tag directory here, do I? So do that first. So again, this is the brute force approach. I can just go get the tag, go get the thing that I want. What am I doing? Control C. Copy paste. And if I don't give it a file argument, it just uses the same file. So this gives me forms.py. So all I'm doing is basically pulling the changes over manually from another repo that I've checked out the interesting stuff here with just a git checkout using detached head over there in this other repo. So I've got myself onto this commit in this other repo, and I'm just bringing stuff over into my repo that I need and just stitching it together on my own. So similarly, I would go to URLs, which already exists for me, but I'm just going to change it manually based on what I see in the, actually it doesn't exist here for me either at that point. Because remember, I'm way back on master, so a lot of the stuff isn't even here. So, I have to grab that file too, URLs and views and all that. But anyway, that's an alternative to the straight git cherry pick. So the idea is that we're taking changes and, making them in parallel as a team. You may or may not be able to bring them straight over from these kind of reference implementation of those changes. If you can, great. If you can't, the cherry pick's not going to work the best for you. So I don't know if that's a good answer or not, but your mileage may vary.
That helped a lot. Thank you.
Sure. Any other questions? I want to do a little bit of wrap up for about 10 minutes and then give you guys another more practice time for another 20 minutes and then call it a day. So, okay, some wrap up. We look back at our syllabus. We've got most of this covered, actually. I was looking through it. Just a couple things I want to point out. Here's one thing. I haven't mentioned this yet, but a git pull is actually two operations. It's a fetch, which basically says, okay, here's everything I need in order to do this thing I'm going to do, which is merge all these things. So it pulls all the SHAs down into your local repo database, but it doesn't do the merge yet. So a pull is a fetch and a merge. So if you just do the fetch, you get all those things down, but they're not put onto your branch, or not even attempted to be put on there. So sometimes that's handy if you want to, take a look at what's there without having to do the merge. There are cases that come in handy. And then then if you decide you do, you can just go ahead and get merge master. Or origin master. So just keep in mind, it's a two-step operation. You don't have to do both steps. You can just break it up into a fetch and then a merge as the situation requires. We talked about detached head. Rebase. Let me show you. So yeah, we talked about this. We talked about this fetch versus pull. Most of this we've talked about: git add, status, diff, commit, reset, branch merge, stash, cherry pick. Bisect we won't talk about. It's kind of fun, but end up not using it very much. But you can follow that gitscm.com link if you want to find out more about it. It's kind of an automatic way to do a binary search of a bad commit using a test script of some kind. But rebase is fun. So let's see where I'm at here. Yeah, so I've made some changes. You've seen some of those in my source tree. And some of those changes, like these guys here, I don't really, if I were going to share this, I wouldn't want to push up a bunch of commits that said, hey, here's a typo, here's another typo, here's a third typo. I just want to use this clarify forking instructions as the description of what I'm doing as one commit. So here's how rebase can help with that. So what you do with rebase is in this context, I'm going to find a place where I want to start from, and then I'll open everything up for modifying. Starting from this point. So if we look at our graph here, probably the good place to start, you can start anywhere, but it has to be at least one before anything you want to change. So I'll start at this 3ED4 place. So git rebase, I'm going to go -I for interactive, and then give it that SHA, 3ED4. So apologies ahead of time. This is going to pop me into Vim, but you can also pop into code with some environment settings. that unfortunately I haven't written down what you do for code. I will look that up. So my bad, but bear with me. So either way, you get into this editor of your commits, right? So here are the commits. Each line is the commit after that commit that I indicated. So that's what it kind of says here. Everything hash is a comment, so nothing's to hash, just concerned, just telling me what's going on. But it has a lot of handy documentation here. So all I'm going to do for this particular rebase is basically take these two commits and basically squash them into this commit. So the content will be the same, but it'll all be one commit instead of three. So how I do that, it says, is to change the pick word here to a squash or an S. So I can say squash or I can say S, either one. And they're going to just roll up into this one commit. And so then if I get out of my editor, which Shift ZZ for Vim, then it goes to the next step and says, okay, here you go. And by the way, what comment do you want for this rolled up commit? And if I get out of this, it will save all these comments, but I don't want that. So I take away anything that isn't already commented out with the hash. And yeah, that's good. I want everything to be described by this comment here, which I can also change. But you know, it looks pretty good. You make it a little bit. And then in this case, it was a pretty easy rebase, so there are no collisions. You can get conflicts on a rebase too, but we didn't. A straight squash really doesn't result in conflicts. So there it is. What happened? Let's see on our graph. So notice, like, this is still here, but it's on a different branch now because we diverged. And actually, that's a problem because we've already pushed this up, right? So that's my next comment, is that when you do this rebase, if you're changing history that you've already pushed up to the remote, then you're going to either have to force push it, do a push-F to say, no, I want to make this thing go over here without doing any kind of merge. And that makes your teammates mad because now their stuff doesn't match what's remote anymore. Like their pointer to origin master is now no longer the same pointer that it last checked, and it's not reachable like it was. So their Git will get upset with that, and they'll have to do some like fetch and resets and whatnot, perhaps, to catch up with what you've done. So the moral is, do a rebase, it's great, but don't do a rebase on stuff that you've already shared with somebody else. Do it, on things you've only got locally, get it nice, and then put it up ahead of stuff you've shared with the rest of your team. But that being said, do a rebase, because it really cleans up. You can really clean up your code and make it nice. You can also use rebase you can switch those commits around if you want to do them in a different order. So you can do several different things with Git rebase. But be careful, that you are only rebasing stuff that's not changing history you've shared by pushing. Any questions on that? There's a link to the SCM page on that as well, so that's worth going over at your leisure. And then, there's where's that at? At the bottom of the documentation, there is a, so if you're on the original repo, README, and you go down to the curriculum, where's the curriculum link? Here, all the way at the end is the references. Most of those are Git SCM references. And then if you want to dig into Bash, there's a couple references here. This one's wrong, but I'll fix that. But the Bash tutorial should be good. Yeah. And then great tool, works everywhere. Be your own best friend. So just my opinion from being coding since 1985, when Vim was still a thing, even back then. Okay, that's about all I have. I'm going to actually put a link to before I forget, I'll put it out there on the Oscar Platoon. This is a survey that appreciate if you get a chance to go through there. It's only like 5 questions, but help me know what to do to pay it forward for the next cohort. So at this point, feel free to go break back out into your rooms if they're still there, and then right at the top of the hour, I'll have Tom call us all back and just see if there's any outstanding questions, and then we'll be done for the day. But